This is Lesson 11 in our Calculus 1 series, the product and quotient rules. In Lesson 10, we learned these basic differentiation rules. And in this lesson, we're going to learn how to take the derivative of a product of functions and of a quotient of functions. So we'll start with the product rule. The product rule says the derivative of the product f of x times g of x is equal to f prime of x times g of x plus f of x times g prime of x. So take the derivative of the first, multiply by the second, plus first times derivative of the second. So for example, if we have a function like y equals x squared sine x, the product rule says the derivative here is going to be the derivative of x squared, multiply that by sine x, plus x squared times the derivative of sine x. So that's going to be 2x sine x plus x squared cosine x. And that's y prime, our derivative. Here, we have y equals x squared plus 2x plus 1 multiplied by 2x to the third minus 2x. And we saw similar problems in Lesson 10, and in that lesson, all we could do is multiply out and then take the derivative. And we can certainly do that here, and we'll do that in a minute. But let's first solve this by using the product rule. The product rule says take the derivative of the first factor, multiply by the second, plus the first factor times the derivative of the second. So here we have 2x plus 2 multiplied by 2x to the third minus 2x. And here we have x squared plus 2x plus 1 multiplied by 6x squared minus 2. And since we were using the product rule to avoid having to multiply out, we'll just leave it here for now. If we had multiplied out first to take the derivative, multiplying out here gives us 2x to the fifth minus 2x to the third plus 4x to the fourth minus 4x squared plus 2x to the third minus 2x, which simplifies to 2x to the fifth plus 4x to the fourth minus 4x squared minus 2x. And then taking the derivative gives us 10x to the fourth plus 16x to the third minus 8x to the first minus 2. And so now we just want to show that these two are the same. And so now let's just multiply out this solution just to see that we get the same answer. And it does in fact simplify to the same derivative. Let's take a look at another example. Y equals 3 radical x cosine x. So here I'm going to consider 3 radical x my first function and cosine x my second function. So the product rule says take the derivative of 3 radical x, multiply that by cosine x, plus 3 radical x times the derivative of cosine x. So 3 radical x we know is 3 times x to the 1/2. So its derivative is going to have a constant multiple of 3, and then 1/2 x to the negative 1/2 power. And the derivative here of cosine x is negative sine x. Don't forget to use parentheses here. I don't want this to magically turn into subtraction. And so simplifying, we're here. We want to take this x to the 1/2 power down to the denominator with a 2. So we have 3 cosine x over 2 radical x minus 3 radical x sine x. Now let's take a look at another. Suppose h of x is equal to f of x sine x for some f of x with f of pi over 3 equaling 4 and f prime of pi over 3 equaling negative 2. Find h prime of pi over 3. So here we're asked to take the derivative of h of x, but all we know is that it has this function f of x here. We don't have the formula for f of x. But that's okay. We do have enough information to be able to find h prime of pi over 3. So let's use the product rule to take the derivative here because we have a product of functions. So h prime of x is going to be f prime of x sine of x plus f of x multiplied by the derivative of sine of x, which is cosine x. So here we have a representation for h prime, and now we're asked to find h prime of pi over 3. So let's plug pi over 3 in each of these spots. So h prime of pi over 3 is equal to f prime of pi over 3 times sine of pi over 3 plus f of pi over 3 times cosine of pi over 3. We were given f prime of pi over 3 to be negative 2. And we were given f of pi over 3 to be 4. We know that sine of pi over 3 is radical 3 over 2, and cosine of pi over 3 is 1/2. So simplifying here, the 2's cancel, we get negative radical 3, and here we cancel a factor of 2, so we get negative radical 3 plus 2. Now let's take a look at the quotient rule. Here we have a rule for finding the derivative of a quotient of functions. So the derivative of f of x over g of x is equal to g of x times f prime of x minus f of x g prime of x over g of x squared. Bottom times derivative of the top minus top times derivative of the bottom over bottom squared. So for example, y is equal to 3 sine x over x squared plus 2x. We'll have a derivative that looks like x squared plus 2x multiplied by the derivative of 3 sine x, that's bottom times derivative of the top, minus 3 sine x times the derivative of x squared plus 2x, top times derivative of the bottom, over bottom squared, so over x squared plus 2x quantity squared. Taking the derivative of 3 sine x, we have 3 cosine x, and the derivative of x squared plus 2x is going to be 2x plus 2, and so now we're here. And there isn't much simplification we can do here, but I would at least want to take this 3 and bring it out in front of that term. We could also multiply it into the x squared plus 2x. We could also multiply this 3 into the 2x plus 2 and bring that out front, and so I would leave the solution here. Let's take a look at another. Y is equal to tan x. Now, we know that tangent x is defined to be sine x over cosine x, so in order to find the derivative of tan x, we can recognize it as the quotient and use the quotient rule. So its derivative is going to be cosine x times the derivative of sine x minus sine x times the derivative of cosine x, all over cosine x quantity squared. So that's cosine x times cosine x minus sine x times a negative sine x over cosine x quantity squared. Cosine x quantity squared can be written as cosine squared x. Here the negatives become a positive and we get sine squared x here, so our numerator is cosine squared x plus sine squared x, which we know is equal to 1 for all x. And we have a cosine squared x in the denominator. So we have 1 over cosine squared x, this is secant squared x. So the derivative of tan x is equal to secant squared x. Now I'd like you to take a few minutes and show that the derivative of secant x is equal to secant x tan x by using the quotient rule. Remember that secant x is 1 over cosine x, like we just saw. So you're going to start with that and use the quotient rule. Please pause the video and work on that. So the derivative of secant x is the derivative of 1 over cosine x. And so we're going to use the quotient rule, that's cosine x times the derivative of 1 minus 1 times the derivative of cosine x, all over cosine x quantity squared. The derivative of 1 is 0, so this term goes away. And the derivative of cosine x is negative sine x. So here we have a sine x over cosine x quantity squared. And we were asked to show that this derivative is equal to secant x tangent x. So we recognize that we should break this denominator into its factors of cosine x. And we have 1 over cosine x multiplied by sine x over cosine x. And so this is the form we were looking for, secant x times tan x. So the derivative of secant x is equal to secant x times tan x. Similarly, it can be shown that the derivative of cosecant x is equal to negative cosecant x cotangent x, and the derivative of cotangent x is negative cosecant squared x. So I encourage you to try those on your own. Now let's take a look at this problem. Find an equation of the tangent line to f of x equals tan x at x equals pi over 4. We just found that the derivative of tan x is secant squared x, so now let's use that to find an equation of this tangent line. Please pause the video and work on that. At x equals pi over 4, the y value we have is f of pi over 4, that's tan of pi over 4, that's 1. So the point of tangency is pi over 4, comma 1. For the slope, we know that we need f prime of pi over 4. We said that f prime of x is equal to secant squared x, so we need secant squared of pi over 4. Remember that this is just shorthand notation for secant of pi over 4 quantity squared. And secant of pi over 4 we know is 1 over cosine pi over 4. Cosine of pi over 4 is radical 2 over 2. So now I'm squaring top and bottom before I simplify, and so I get 1 over 2 fourths, which is 4 halves, or 2. So 2 is our slope here for the tangent line. So y minus 1 is equal to 2 times x minus pi over 4. This right-hand side gets expanded as 2x minus pi over 2. We bring over the 1, and we have y equals 2x minus pi over 2 plus 1. So this is an equation for the tangent line, 2 f of x equals tan x at x equals pi over 4. And that looks like this. So here's our graph for y equals tan x, and here's our tangent line, y equals 2x minus pi over 2 plus 1. Now let's take a look at this one. We've got a product within a quotient. Notice in the numerator we have a product of functions, and then that's within a quotient of functions. So that means we're going to have the product rule within the quotient rule. And so we should start with the quotient rule. So y prime here is going to be bottom times derivative of the top minus top times derivative of the bottom over bottom squared. Now when we take this derivative here, we're going to use the product rule. And so that result looks like this. Derivative of 2x to the third sine x is going to be derivative of 2x to the third times sine x plus 2x to the third times the derivative of sine x. Everything else I'm just copying down now. Just going to work on this and simplify. And so that's going to be 6x squared times sine x plus 2x to the third times cosine x. And here, the derivative of cosine x plus 1 is going to be negative sine x plus 0. So that goes in here as a negative sine x. Again, don't forget to use your parentheses. So now we're here, and it looks kind of messy, but we should probably expand and simplify the numerator in case anything cancels. So expanding here, we get 6x squared sine x cosine x plus 6x squared sine x plus 2x to the third cosine squared x plus 2x to the third cosine x. And then here we have two negatives to make a positive, and we have 2x to the third sine squared x. Notice we have a 2x to the third cosine square x plus a 2x to the third sine square x, so that's 2x to the third times sine square x plus cosine square x. And we know that this simplifies to 1. And so now, let's just factor out whatever we can. Let's factor out a 2x squared. That's going to leave us with 3 sine x cosine x plus 3 sine x plus x cosine x plus x. And notice we can factor a little bit more here. We have a 3 sine x that factors from the first two terms in here, leaving a cosine x plus 1. And we have an x that factors, leaving a cosine x plus 1. So that tells us we can factor what's in the parentheses as 3 sine x plus x multiplied by cosine x plus 1. And then we have a factor in the numerator and denominator of cosine x plus 1 that will cancel. And so we're here, 2x squared times 3 sine x plus x over cosine x plus 1. And that's our derivative. Now for the next one, for f of x equals x squared times sine x plus cosine x, I want you to find f prime and f double prime. So please pause the video and work on that. Here we have a product of functions, so we want to make sure we use the product rule. So we have the derivative of x squared times sine x plus cosine x plus x squared times the derivative of sine x plus cosine x. Derivative of x squared is 2x. The derivative here is cosine x minus sine x. And we can leave our first derivative here. For our second derivative, we're going to have to use the product rule twice. The product rule is going to be applied on each one of these terms. So for the first term, we're going to have derivative of 2x times sine x plus cosine x plus 2x times the derivative of sine x plus cosine x. Now let's use the product rule on this term. So we have plus the derivative of x squared times cosine x minus sine x plus x squared times the derivative cosine x minus sine x. The derivative of 2x is 2. The derivative of sine x plus cosine x is cosine x minus sine x. That's here. Derivative of x squared is 2x. Derivative of cosine x minus sine x is negative sine x minus cosine x. Now we should expand and simplify so at least we can collect all our sine terms together and all our cosine terms together. So expanding, we're here. And then collecting our sine and cosine terms, we can refactor like this. And so this is our second derivative. Now let's take a look at the next example. At which x values is the tangent line to f of x parallel to x plus y equals 5? Find equations for those tangent lines. Well, if we're talking about our tangent lines being parallel to x plus y equals 5, we know that parallel lines have the same slope. So we're being told that the slope of our tangent line should be the same as the slope of this line. Well, to be able to read off the slope, we should solve for y. Y is equal to negative x plus 5. That tells us the slope is equal to negative 1. So we're trying to find the x values for which this function has a slope of negative 1. That means we're trying to find the x values for which f prime of x is equal to negative 1. So let's find f prime and let's set it equal to negative 1. Please pause the video and work on that. Using the quotient rule, we have bottom times derivative of the top minus top times derivative of the bottom over bottom squared. So it's x minus 1 times 2 minus 2x plus 2 times 1. Don't forget to use parentheses here so that you don't lose your negative sign as it applies to the 2 here. Simplifying the numerator, our 2x's cancel, and we get negative 4 over x minus 1 quantity squared. This is our derivative function, and we're looking for the x values, remember, for which f prime of x is equal to negative 1. So we want to set this equal to negative 1 and solve for x. If we multiply both sides by x minus 1 quantity squared, we're here. Multiply both sides by a negative 1. And you could expand and then refactor, or you could square root at this point and then move over your 1. So if we square root here, we get x minus 1 is equal to positive or negative radical 4, or positive and negative 2. So then adding a 1 gives us x equals 3, or x equals negative 1. So we found the x values at which the tangent line is parallel to the line we were given. We were also asked to find equations of those tangent lines. The tangent line at x equals negative 1 has the point negative 1 f of negative 1. F of negative 1 is equal to 0. So that's the point negative 1, 0. And we said the slope is negative 1. So we're here, y is equal to negative x minus 1. At x equals 3, the point is 3 comma f of 3. So that's 3 comma 4. And so y minus 4 is equal to negative 1, x minus 3. Simplifying, we get y equals negative x plus 7. And so these are equations for the tangent lines at these points. So we were given f of x equals 2x plus 2 over x minus 1. And we were given this line, x plus y equals 5, the blue line here. and we were asked to find the points at which the tangent line to the curve is parallel to the given line. So we found that that happens at x equals 3 and at x equals -1. And so in this lesson, we learned how to take the derivative of a product of functions or of a quotient of functions. In the next lesson, we'll talk about how to take the derivative of a composition of functions when you have one function plugged inside another. And this concludes our lesson on the product and quotient rules.